Here we're given two rational functions. F of x equals 3x minus 2 over 5x squared plus 9x minus 2. And g of x equals x plus 9 over x squared plus 10x plus 9. And we're asked to find the domains of these rational functions. Let's work on part A first. Step 1, we're going to set the denominator equal to 0. Step 2, we're going to solve this equation for x to find the x's that make the denominator 0. We compare it to the standard form to identify a, b, and c. And then we are going to do factoring by the diamond. A times c at the top, b at the bottom. A times c is negative 10. We're going to multiply to get that. And at the bottom we have the b value 9. So we're looking for two values that multiply together to give you negative 10, add together to give you 9. And the answers are 10 and negative 1. And just think about it. When you multiply them together, you get negative 10. When you add them together, you get 9. Now, what do we do with these two values, 10 and negative 1? We take the original equation we're trying to solve and extract the 9x in the middle, replace it with those two values with x's, plus 10x minus x. Now we factor by grouping. Out of the first group, we pull out a 5x. Out of the second group, a negative 1, and the miracle occurs. Factor the miracle factor in the front, times what remains when we strip it away from the first piece, it leaves 5x. And when we strip away the big miracle factor from the second piece, it leaves negative 1. Bring down the equal sign and the 0. Now you're factored equal to 0, so you're allowed to set each of your factors equal to 0 with the union symbol and solve each of the little equations. We get x equals negative 2 and x equals 1/5. So we just found the x values that make the denominator of our rational function 0. Those values are not allowed. We don't want a 0 denominator, so we're going to throw them away from the list of all real numbers to come up with the domain of this function. The domain is a set of all real numbers x such that x is not equal to negative 2, comma, x is not equal to 1/5. It's every other real number. Okay, part B. Step 1, we're going to set the denominator equal to 0. X squared plus 10x plus 9 equals 0. We're going to solve this equation to find the x values that make the denominator 0. Then we'll throw those away. We factor the left side by guessing x plus 9 times x plus 1. And then we set each of the factors equal to 0 and solve the little equations. We get x equals negative 9 together with, union with, x equals negative 1. So we're going to write the domain as a list of all real numbers except those two values because they make the denominator 0. So step 3, the domain of g is equal to curly set bracket all real numbers x such that x is not negative 9, comma, x is not negative 1. Now what I want you to notice is that our question that we have for part B actually simplifies. We can factor and cancel g of x, in which case we can factor out a x plus 9 in the bottom to cancel with the x plus 9 on the top, and it simplifies our function to g of x equals 1 over x plus 1. Now, if you just looked at that version of the rational function, you would assume only x equals negative 1 would be excluded in the domain. But the fact is that this function started life more complicated than 1 over x plus 1. It started as x plus 9 over x squared plus 10x plus 9. So what we have to remember is that rational functions never forget their roots. They never forget what they were before you simplified them. Therefore, the domain of g, even after simplifying it, still has to carry along that exclusion of negative 9. It doesn't seem like it makes sense unless you know which function you actually started with before you simplified it. So even in the simplified form, since we started with the more complicated form, the domain is all real numbers x such that x is not equal to negative 9, comma, x is not equal to negative 1.